In this question, we are going to use compound angle formulas to evaluate the sine of 195 degrees, the cos of 195 degrees, and the tan of 195 degrees. So we begin by saying that the sine, we can say that 195 degrees is equal to 135 degrees plus 60 degrees. The significance of this is that 135 degrees and 60 degrees are both angles for which we know sine, cos, and tan. So we can say that the sine of 195 degrees is equal to the sine of 135 degrees plus 60 degrees. And since sine A plus B is equal to sine A cos B plus cos A sine B, we can say that the sine of 135 plus 60 is equal to the sine of 135 cos of 60 plus the cos of 135 sine of 60. And the sine of 135 degrees is equal to root 2 over 2. And the cos of 60 degrees is equal to 1 over 2. The cos of 135 degrees is equal to negative root 2 over 2. And the sine of 60 degrees is equal to root 3 over 2. And so what we get, multiplying through, is root 2 over 4 minus root 6 over 4, which ultimately just equals root 2 minus root 6 quantity over 4. Okay? So we've got a value for the sine of 195 degrees. Now, what's the cos of 195 degrees? Well, again, we can use 135 and 160 as our angles to combine to be 95 degrees. Now, just so you know, it doesn't have to be 135 and 60. It could be 150 and 45. Or it could even be 225 minus 30. So long as we're making it equal 195 out of angles for which we know. Now, cos angles for which we know the sine and cos without needing a calculator. So now the cos of A plus B is equal to cos A, cos B minus sine A, sine B. And that's one of our compound angle formulas. Okay? Well, the cos of 135 degrees, as we said on the previous page, is equal to negative root 2 over 2. And the cos of 60 degrees, as we said on the previous page, is equal to 1 over 2. The sine of 35 degrees is root 2 of 135 degrees is root 2 over 2, and the sine of 60 degrees is root 3 over 2. So what I end up with, multiplying my numerators and my denominators, is negative root 2 over 4 minus root 6 over 4, which equals negative root 2 minus root 6 quantity over 4. So now I've got a value for the cos of 195. Now to find a value for the tan of 195, I make note of both of those values that I mentioned earlier. And I can say that the tan of 195 is simply equal to the sine of 195 over the cos of 195. So all we're going to do here is we're just going to plug in those fractions that you see in at the top. Now notice that each of those fractions that you see at the top has a rational denominator. We always want to rationalize our denominators because we want to appear sophisticated. So what we have is an opportunity to invert and multiply. And when we cancel out the 4's, we end up with root 2 minus root 6 all over negative root 2 minus root 6. Now, at this point, we see we've got an irrational denominator, and specifically it's an irrational denominator that has two terms in it. The way we're going to rationalize it is by multiplying numerator and denominator by the conjugate of the denominator. Well, what's the conjugate of negative root 2 minus root 6? The answer is negative root 2 plus root 6. All we're doing is we're changing the sign of the second term. So we're just changing that negative sign right in front where the arrow is. We're just changing that to a positive sign. Now, when you multiply a new factor into the denominator, you definitely need to multiply that same new factor into the numerator, so we do that. Now what we're going to do is distribute. That root 2 will multiply by that negative root 2, and that root 2 will multiply by that positive root 6. So when we multiply the root 2 by negative root 2, we get negative root 4. When we multiply the root 2 by the root 6, we get positive root 12. Then when we multiply that negative root 6 by that negative root 2, we get another positive root 12. And when we multiply that negative root 6 by that positive root 6, we get negative root 36. Okay? Now we do the same expanding in the denominator. Negative root 2 times negative root 2 is positive root 4. Negative root 2 times positive root 6 is negative root 12. Negative root 6 times negative root 2 is positive root 12. And negative root 6 times positive root 6 is negative root 36. Now what's neat about this denominator is the term root 4 will simplify to an integer, and the term root 36 will simplify to an integer. And the irrational parts, the negative root 12 plus root 12, they cancel each other out. It's awesome. So up top, that negative root 4, the first term in the numerator is negative 2. We have positive root 12 and positive root 12, so that becomes plus 2 root 12. The negative root 36 becomes negative 6. And we divide by that root 4 in the denominator is a 2. The negative root 12 and positive root 12 cancel out. And we're subtracting root 36, which is like subtracting 6. Okay, so now I see in the numerator I've got 2 root 12. Well, I have an opportunity to simplify that, because root 12 is really the same as, if you look up at the top, root 12 is really the same as root 4 root 3, which is the same as 2 root 3. And so what I'm going to do in my next step, I'm going to collect this negative 2 and negative 6, and that's going to be negative 8. And then that 2 root 12 will become 2 times 2 root 3. And of course, I subtract 2 minus 6 in the denominator, I get negative 4. Now, continuing on, I have negative 8 plus 4 root 3 in the numerator, and in the denominator, I've got negative 4. I can factor negative 4 out of the denominator, or sorry, out of the numerator, and that'll give me a 2 minus root 3. In other words, negative 4 times 2 will be negative 8, and negative 4 times negative root 3 will be positive 4 root 3. And then in my denominator is still negative 4. So I can cancel out this denominator with that factor, and I'm left with a final answer for the sine of, for the tan of 195, because that's what we're looking for here. The tan of 195 is equal to 2 minus root 3.